Welcome to the DIY Honda Garage channel. This presentation focuses on diagnosing the DTC P04F1-92, which indicates a low purge flow in the evaporative emission system of the Honda CR-V 2023 and newer models. This error code is generated when the Engine Control Module, ECM, detects that the pressure from the Evaporator Level Control Module, ELCM, sensor is lower than expected during low engine load. The ELCM plays a critical role in managing fuel vapor emissions by controlling the flow of vapors from the evap system to the intake manifold for combustion. The component locations critical for this diagnosis include the evap canister purge valve, fuel tank, and associated tubing. A thorough inspection of the system is crucial to pinpointing the problem, which can affect emissions and vehicle performance. The error code DTC P04F1-92, which stands for Evaporative Emission System Low Purge Flow, indicates a malfunction within the evap system of the Honda CR-V. The affected components primarily include the evap canister purge valve, the ELCM sensor, and the fuel tank system. The ELCM sensor monitors the pressure level in the evap system, and if it falls below a predetermined threshold during low engine load conditions, a diagnostic trouble code is stored. The evap canister, typically located in the rear of the vehicle near the fuel tank, is crucial for capturing and venting fuel vapors. The continuous operation of this system ensures minimal emissions and helps the engine run efficiently by recycling fuel vapors for combustion. The vehicle's onboard diagnostics monitor these systems closely to maintain compliance with emission standards and optimize engine performance. The DTC P04F1-92 can arise from several potential causes, each requiring careful inspection. One common issue is a faulty evap canister purge valve, which may not open or close correctly, leading to insufficient vapor flow if it is stuck closed. Another cause could be blockages within the evap purge system, which can occur due to debris or corrosion, preventing the proper venting of fuel vapors. Additionally, leaks in any of the evap components can significantly affect system pressure and cause the error code to be triggered. The ELCM sensor itself may also present issues, such as incorrect readings or complete failure, which would directly lead to low pressure readings detected by the ECM. Overall, these various factors must be examined systematically to identify and rectify the root cause effectively. When dealing with DTC P04F1-92, you may notice several symptoms impacting the vehicle's operation. The most immediate observation is the illumination of the check engine light on the dashboard, which signifies an ongoing malfunction. Drivers might also experience poor engine performance, characterized by rough idling or stalling, as the evap system plays a role in fuel vapors management necessary for combustion. Another critical symptom is decreased fuel efficiency, indicating that the engine might be running less optimally due to improper fuel vapor routing. Finally, if the vehicle is subjected to an emissions inspection, failure may occur due to the malfunctioning evap system, leading to potential legal ramifications and costly repairs. Thus, recognizing these symptoms early is vital for timely intervention. The first troubleshooting step involves preparing the vehicle for diagnostics. Begin by turning the ignition to the on mode without starting the engine. This action initially powers up the vehicle's electronic systems needed for the test. Next, utilize the Honda Diagnostic System HDS to select the evap leak check module test. The HDS is an advanced tool that allows for readings and tests on various vehicle systems, including the evap. Once the test is initiated, if the results indicate that the failure condition is duplicated, It confirms that there is indeed a malfunction that requires further investigation. The outcome of this step is crucial, as it establishes whether the system is operating within normal parameters or if further inspections are warranted. Following the confirmation of a malfunction, the next step is to inspect the evap canister purge valve. This component's role is to control the flow of fuel vapors from the evap canister to the intake manifold. So it's crucial to ensure it operates correctly. Begin by visually assessing the valve for any signs of damage or blockage. Next, check the valve's operation using the vacuum gauge. It should open and close in response to applied pressure or vacuum, as specified in the diagnostic procedures. If the valve remains stuck in the open or closed position, it requires replacement. Verify that the valve creates a proper seal during operation to prevent any vapor leaks, which can lead to erroneous sensor readings and further complications in the evap system. In this troubleshooting step, your focus shifts to inspecting Evat Purge System 1 for any potential issues. This subsystem plays a pivotal role in allowing vapors to flow from the fuel tank to the engine for combustion. Start the inspection by checking for any poor connections, which could disrupt the system's pressure balance. Then, examine the entire system for blockages or leaks. These conditions could significantly impair the evap's efficiency. If you notice any damages or discrepancies during the visual inspection, those components should be addressed immediately. A well-functioning Evap Purge System 1 is essential for effective vapor management. Allowing any deficiencies in this area can lead to the P04F1 code being stored. The fourth step in diagnosing DTC P04F1-92 involves a thorough inspection of Evap Purge System 2. This inspection is crucial, as blockages or leaks in this subsystem can directly impact the system's ability to manage fuel vapors. Begin by disconnecting the purge tube from the evap canister purge valve. Then, follow the designated test procedures outlined in the diagnostic manual. You may need to utilize a vacuum pump to apply pressure and assess the system for any abnormal responses. If pressure does not hold, this indicates a blockage or leak that requires further investigation. Proper function of Evap Purge System 2 is vital for the overall health of the evap system and preventing the triggering of fault codes. For this troubleshooting step, the focus shifts to the ELCM system, which is crucial for monitoring and regulating pressure within the evap system. Thoroughly inspect all components associated with the ELCM for any physical signs of damage, such as cracks or corrosion, which could affect performance. Also, verify that there are no blockages or kinks in the lines leading to and from the ELCM, as these can interfere with proper functioning. Additionally, check the connectivity and ensure that all electrical connections are secure and free from corrosion. The ELCM must work seamlessly with the ECM to ensure efficient vapor flow. Any irregularities here can lead to a reset of the DTC and further complications. This step involves inspecting the main flap unit, an essential component in managing the vapor flow effectively within the evap system. Begin by checking the shutoff valve of the main flap unit to ensure it is closed properly during operation, as failure to do so can lead to unwanted vapor escape. Moreover, pay close attention to the flap seal and the mating surface for any damage or missing parts, which would compromise the integrity of vapor containment. Any defects in the main flap unit could lead to system failures or cause the DTC to reappear. It's essential to verify that this component operates correctly before proceeding to subsequent inspections in the evap system. In this final troubleshooting step, the inspection broadens to include the fuel tank system associated with the evap setup. Begin by disconnecting the fuel vent tube from the evap canister, as this will enable a proper assessment of the system's integrity. Use a vacuum pump, once again, to test for any leaks or blockages within the fuel tank system. If the vacuum holds, it indicates the system's basic integrity is intact. However, any failure to hold vacuum means there could be a leak or blockage that must be addressed. Ensure that the connections to the vent tubes are secure and free from damage or corrosion, as this could lead to pressure inconsistencies and trigger the P04F1-92 code. After performing all necessary repairs prompted by the DTC P04F1-92 troubleshooting steps, it's imperative to verify repairs have resolved the issue. Start by connecting the diagnostic tool to clear DTCs from the vehicle system, ensuring that all previous codes are no longer recorded. Following this, conduct a test drive under varied driving conditions to assess whether any symptoms return during operation. It is essential to monitor the vehicle closely during this phase. If any error codes reappear, further inspection into the EVAP system may be necessary. Successful completion of these steps indicates a successful resolution, restoring the vehicle to optimal functioning without triggering fault codes. Preventive maintenance is critical in ensuring that the EVAP system remains functional and does not lead to the triggering of DTCs like P04F1-92 in the future. Regular inspections of all EVAP components, including the canister, purge valves, and associated tubing, can help identify wear and tear before they lead to significant issues. It's vital to ensure that all connections are tight and free from corrosion or damage that could lead to vapor leaks. Following the manufacturer's recommended service intervals and guidelines is also beneficial in preventing system failures. Proper care of the EVAP system not only maintains vehicle performance, but also ensures compliance with emission regulations, ultimately extending the vehicle's lifespan. In summary, DTC P04F1-92 signifies a serious issue within the EVAP system relating to low purge flow, which can adversely affect vehicle performance and emissions compliance. This guide outlined the critical components involved, such as the EVAP canister and ELCM sensor, and highlighted possible causes rooted in each subsystem. The approach provided systematic troubleshooting steps, ensuring thorough diagnostics, leading to effective problem resolution. Timely and accurate diagnosis is key in preventing emission problems, supporting environmental standards, and optimizing vehicle efficiency. Ultimately, a proactive maintenance schedule will not only address existing issues, but also safeguard against future complications that could lead to further DTC triggers. Please like and subscribe to the channel. See you next time.